Player feedback can make or break your game. Even the best mechanics can't save a game if players don't understand what they're looking for or what they can do. In this Unreal Engine 5 mini-series, we're going to create a simple outline of objects that lets players know how they can interact with those objects or items. Along the way, we'll cover clean blueprint practices, actor components, blueprint interfaces, post-process materials, and non-HUD widgets. In this video, we'll create a post-process outline material, apply it to a post-process volume, set up our objects to display an outline when they're highlighted. My name is Neil with Crustacea Studios. Let's dive on in. So what I'm going to do is I'm going to take everything that we've done here with these print strings, and I'm going to make it to where we get it being called inside of our interaction parent. Because the way that the process is working right now is the line trace is finding what we hit. It's then asking, hey, what are you? What did I hit? And then it's reporting back to us, hey, I hit this. So we're going to build it in a way that instead the line trace is going to look for something, and when it hits something, the object that it hit is going to say, hey, you hit me instead. And so that keeps everything nice and self-contained. So the first thing that we're going to do is we're going to come back to our blueprints here, and we're going to create a new folder, and that folder is going to be called Interfaces. Now, if you haven't worked with interfaces before, that's okay. I'm going to give you a little bit of a crash course here, but I should have another video out soon that'll kind of cover blueprint interfaces in a little bit more depth. But for right now, just follow along, and I'll explain it as we go. So to create a blueprint interface, we're in our interface folder. We'll right-click. We'll come here to our blueprint option, and we're going to say blueprint interface. Now I'm going to say BPI underscore, and I'm just going to call this interactable interface. So if we open that up, the first thing you're going to notice here is that it looks like our graphs that we have here, but it's just a function. So if you take a look at how we have our line trace function, when we open it up on the side here, it brings us into a self-contained graph. And that's kind of similar here, but instead of writing our code inside of this, what we're going to do is that we're just going to declare this function. So this function is going to be, we'll call this function trace start. Okay, and then we're going to create another one here. It's another function, and we're going to call it trace end. And we don't need to do anything with that other than just declare what these functions are. Now we're going to come back to our interaction parent. So remember, that's where we just have our mesh. And over here under class settings, we're going to scroll down to where it says interface. Now, before I do this, I want you to pay attention over here to the left-hand side. If we were to create, let's say, a function, we can see how our function shows up here. And then a function I could be able to then come, drag in, and then we can connect it up. So keep an eye out on this side of the screen. So class settings, interface, implemented interfaces, we're going to say add. Now this is where calling it a BPI for blueprint interface comes in handy. So we say BPI, interactable interface. And we add that, and you can see here under interfaces, we now have these, what we created here. So we have our trace start and our trace end. So we have our trace start and our trace end. So let's compile and save. Now what these are essentially functions, but I can't just grab and drop. See how it says this function was not marked, or was not marked as a blueprint callable and cannot be placed in a graph. So what that means is this blueprint here, if we said call an editor, that means that we could just be able to call it whenever we wanted to. But what we're going to use this instead of is if we just double click it, it pops up here. And we're going to take our line trace. So on our trace start, we're going to copy this over. And we're going to bring this here. So when we have our trace start, we're just going to plug this in. And then for our display name, what we're going to do is we're just going to say get a reference to ourselves. So that's really simple. Now for our trace end, we're going to do the same thing, but instead over our AC line trace, instead of grabbing this over, we're going to grab our unhighlight. We're going to copy that, bring that over. We're going to hook that up, and then we're just going to call our self one more time. So why did we do that? So an interface allows us to be able to call functions with whatever has the interface on it from another function. So one way we could be able to have our line trace call the function inside of our interaction parent is if we do a cast. So for instance, if I took our hit actor here and I said cast to our BP underscore interaction parent, right? And let's say we plug that in here. Let's say that this was, we'll just say, we'll create a custom event, and we'll just call this interact start for now. And I come off here, I can then say interact start. I can then call this function, this interact start, from inside here, but casting gets really expensive. And since we're doing a line trace on every single frame, that means if we hit something, we're going to be casting every single frame. And so that can get really expensive really fast, especially if we're colliding with a lot of different things. So instead, what we end up doing is we directly off of this hit actor, we just say trace start, and it says trace start message, and we just click on that, and then we can move this over. And if we delete this here, now what we've done is that we're just saying, hey, I'm sending out a message to what's listening here, which is this target. I'm sending a message from my hit actor as the target that is trace start. And because we have trace start here, it's going to call this. So let's go ahead and test this out and we can see it in action. So if I hit play, I come down here. Now everything should work the way that it did. So if we hit this cube, it'll probably pop up. So there we go. We unhighlighted the cube and we highlighted the burger. We highlighted the soda, we unhighlighted the burger. We highlighted the soda, we unhighlighted the other soda. We highlighted the tomato, we unhighlighted the cube. So I'm actually just going to come in here and I'm going to fix that. So that way we're not constantly re-highlighting that cube. So you can see how it is working just as we originally had it set up. But instead of our line trace going, finding what we're hitting and then reporting back as to what we're hitting, we are just having whatever gets hit say, hey, yeah, you've hit me. So let's do the same here. So we're going to remove this and we'll drag this off and we'll just say trace end. And we'll plug this in. And then since we're doing the same thing up here, we'll delete this. We'll drag off here and say trace end. Compile, save. Now if we go ahead and hit play, we'll see that everything is working the exact same way. So the only thing that we lose here is we just lose the color change from down here. We could set that up, but that's just going to be a little bit more work than what we really need. The whole point is that we know that we're unhighlighting when we stop our trace, and we are highlighting, quote unquote, when we do start our trace. So that means now we can build all of our code for how things get highlighted inside of our interactable parent. All right, I'm just going to clean this up a little bit because this is pretty messy. So there we go. So that is a very clean and efficient looking line trace here. All right, back on track. So now that we have our line trace giving us what we need, we can be able to move on towards actually being able to build the outline. So let's go ahead and jump into that. So what we're going to do here is we need to create a new folder. I'm just going to call this materials. And then we're going to come here and say create a new material. So I'm going to call it M for material, and then I'm going to call it PP underscore, and then I'm going to say outline. Now the PP just stands for post-processing, because the way we're going to do the outline is using a post-processing outline versus creating a material that goes around the object, because we only want to highlight the perimeter of the object. And if we do a overlay, anywhere where there's going to be an edge, we're going to be able to see an outline as well. So this gives us more of a different highlight setting. So once we're inside here, we want to change this from surface to post-process. We're going to apply, we're going to save. We're going to do quite a few things here. So I will say that this is something that I did not figure out on my own. I did look this up, but I can help explain what's going on. So we're going to go ahead and give ourselves some room. We're going to come over here and let's get started. So the first thing I'm going to create is I'm going to create a scalar. So if you hold down S and click, this creates a scalar. And I'm going to call this line thickness. I'm going to give this a default value of 3. Then I'm going to create a scene texel. And what this is that this is basically saying 1 unit is 1 pixel. So in a 1920 by 7 or by 1080 screen size, this lets us know that 1 unit is equal to 1 pixel. We're going to drag off here and get a component mask. And we're going to just enable the red channel. And what this is going to do is that this is going to isolate one specific coordinate. Now the next thing we're going to do is we're going to drag off here. We're going to say multiply. And we're going to multiply these here together. Now the next thing we're going to create here is we're going to hold down S. We're going to create another parameter. And this is going to be our Y offset. Make this capital. And this is going to allow us to be able to adjust the direction. So the way that we're building the outline is that we're going to be taking our item sample and we're going to be testing the perimeter around for an edge. So we need to be able to get a sample of above, to the left, to the right, and to the bottom. And where we see a difference, we're going to then enable a post-process color that's going to be that size. So, and that will depend on our line thickness. So the thicker the line, the bigger the outline. The smaller the line, the smaller the outline. But we need to sample our positive Y, our negative Y, our positive X, and our negative X. So that's what we're creating right now. So this offset will be able to allow us to offset the direction a little bit, but we're going to keep it set at 0 for right now. Then we're going to come here, we're going to drag off our multiply, we're going to say append. Append vector is what we want. We're going to plug that in, and this will give us our sample side from our this is our X, and then our Y offset here. So the next thing we're going to want to grab is a screen position. And from our viewport, we're going to grab another component mask. And we're going to keep this as our red and green channel. So let's bring these a little bit closer. We're then going to add these two together. So right now, if we hook this up, we're just going to get this different range because we haven't created a mask yet. We've only just created the sampling. So let's go ahead and do that, and then we can be able to continue to go from there so we can see what's going on. So we're going to move this back a little bit again. We're going to drag off here, and we're going to look at our scene texture. And we want to set this from scene color to custom depth. Right here. And let's just make a copy of it. We're not going to plug anything into this one. So we're getting the custom depth right now of what we're sampling, and we're comparing it to just our scene's generic custom depth. So to compare that, we want to subtract. We're going to subtract these two. So if they are similar, we're going to get a result of 0, which then means that we have a edge, and anything else means that we don't have an edge. So from here, we then want to grab the absolute values, type in ABS. So that way that means we're always going to get something that's positive. So for whatever reason, this becomes negative. So if we get a negative 0.5, it becomes a positive 0.5. Then from here, we're going to divide. Now this takes whatever this value is, which could be a huge value, and makes it a little bit more manageable because we want to be able to go between 0 and 1. So anything over is going to create some really wonky results. The best thing that we can do here is if we type in 1 and hit and click, we just get a solid value. If you want to make this a scalar, you can, and then this gives you a parameter that you can adjust. But we're most likely not going to be touching this later or want access to it. So let's go ahead, and if we set this to, it's going to be a big number, 1 million. So there's 1,000, 1 million. This means that it's going to take whatever this value is here, and it's going to divide it by 1 million. So instead of getting 500, we're going to be getting, 0.00005 or something along those lines. Then we want to multiply this. And here we want to add a scalar parameter, and this is going to be our edge strength. So this will be how strong our edge is. So we're going to default this to 1. And this will give us a stronger line or a weaker line. So 1 is typically fine, but if we want to be able to adjust that later down the road, we can. So we're taking that value. So for instance, if we have 0.0005 and we want to multiply it by 5,000, that can bring us up to 1. I believe that's the math. If not, I'm sure somebody will correct me, but that's the idea. Then we want to clamp this between 0 and 1. So anything over 1 just becomes 1. Anything under 0 becomes 0. And we're almost done. And remember, this is just currently right now for 1 coordinate. So if we hook this in right now, we're not going to get anything. So we have one last step, which is to set up our color. So we're going to grab our scene texture again. And instead of getting our custom depth, we want to get a post-process input. We're then going to drag off, we're going to create another mask. And we're just going to leave this as red, green, and blue. Then we're going to hold V and click. And this is going to give us a vector parameter, which will allow us to be able to select our color. So let's just go ahead and call this outline color. And we'll set this to something that we can be able to easily identify. Let's do this bright green. I think that'll contrast against everything. We'll come over here. If you hold L and click, you get a lerp node. And we'll plug in our mask into A. Then we'll plug our color outline RGB into B. Then we'll take our clamp. We'll plug that into our alpha. So anything that is above a 1 will have a, or sorry, above a 0 will create the outline, which will be just along our edge. And then we go ahead and plug this into our emissive color. Let that do its thing. Hit apply. Hit OK. So we've only done just one for right now. So we'll be able to see that here if we come in and play test this. But first, we have a few things that we need to get set up here. So we have our material, which is all good. Now we need to set up our post-process volume. So we can check to see if we already have one in the level by coming over here to our outliner and type in post, which doesn't look like we do. So we need to add one. We'll come here to our volumes. So if we click this little box, come down to volumes, we can look for post-process volume. That's going to drop it right there. I'm just going to zero this out so it shows up there, and then drag it up a bit so that way we know that it's centered. I'm going to come here and I'm going to say unbound, or which gives us infinite extents, which means that if this extends to the entire level, it's not just contained within that box. So the next thing we need to do here then is search for our post-process materials. So if you scroll all the way down, you'll see it right above, a little bit further. It'll be right above ambient cube map. So you could also type in here post-process and it brings that up. So we see we have an array. So we're going to hit the plus sign, we're going to hit choose, and we're going to say asset reference. And for right now, we're just going to drop our outline in so that way we can be able to see. We see our entire screen goes black because if this is set to post-process input 1, that causes, and we hit apply, that causes our screen to go black. So we want to make sure that this is on post-process input 0 because it is a part of this post-process array here. So 0 is the first one. 1 would be the second one, which doesn't exist. So we're not quite done. So if we hit play here, and we come over here, we'll notice that nothing happens when we look at them. Because what we need to do is we need to enable custom depth when we look at these items. So to do that, we're going to come back over to our interaction parent. I'm just going to drag this over here. So this is where we start building our code off of this here. So I'm going to leave these here just so that we can still be able to verify and see what happens. But we're just going to drag our mesh out. And we're going to say custom depth. We can say set render custom depth. We'll plug this in here so when it's highlighted, we want to turn it to true. And when it is unhighlighted, we want to turn it to false. And then make sure that's connected here. So we'll be able to see now, we'll have a little bit of an outline on one side when we look at it. So if we come here, we see nothing, and then see how we have just a tiny little bit of an outline? So that'll change depending on where we sample, because right now we're only sampling one direction. It looks like the whole thing is outlined right now, but if we were to change this offset, let's take a look at our outline. If we come back here and we were to change this offset to, like, let's say 0.1, and come and take a look, we're going to see how it only moves up in that one direction because it's only sampling vertically right now. So the next thing that we want to do is we want to sample our area looking downward, which is going to be easy enough. All we have to do is we just take this and we just duplicate all of it. And instead of just plugging in here, we're just going to add a couple of nodes. We're going to add a multiply here. So if you hold down M and left click, and we're going to multiply it by -1. Plug that in there and there. And then do the same here. Hold down M. Plug that in. Multiply it by -1. Because positive is going up, so negative is going down. Then all we have to do is, from our absolute values, we just do an add node, and we add these together, and then we plug that into our A. So if I hit play, because we're still at that offset 1, we'll see now it is offset to up and down. The next thing that we have to do is now do our X, which our X is very simple. So we're just going to take all of this, we're going to duplicate it one more time, so that way we get everything. And instead of having a Y offset, we're going to create an X offset. So we'll hold down S, type that in, we'll say X offset. Make sure that is an underscore. And then all we have to do is then just swap these. So this will plug into the B, and this will plug into the A. And we'll duplicate our X offset over here. And again, this plugs into the B. And since this is our opposite side, we'll plug this into the A. So editing Neil here, one thing I noticed as I was putting this together is our mask for our X offset was set incorrectly. So since we had copied everything over directly, it was set to our mask R. So what we need to do for our X offset is that we just need to change our mask from red to green. It'll work if it is red, but if we keep it separate, then we know for sure our X is going to be on the green channel and our Y is going to be on the red channel. So it just helps us make sure to keep them separated if we need to access them a little bit later. So I wanted to just make that correction for you while I caught it. For the rest of the video, you will see the X offset set as R. Like I said, it's not going to visually affect anything. This is just more so just to kind of keep everything separate in channels if we ever want to just get the green channel and the X information, we can be able to do that. So just keep that in mind moving forward. Then we'll copy this add node. We'll drop it in here. We'll add these two together. And then the last thing I have to do is then copy another add node, and then we just add the values of both of these together. And then this plugs into our divide. So now we'll see everything, and let's set the X offset to 0.1 as well, and that'll automatically update over here. So we can see now that we're going to be sampling in all directions. See, now we have a sample in each direction, which is pretty cool. So I'm going to go ahead and set these back to 0 for both our X and our Y. So that way we can come down here and take a look, and we should just have a nice clean outline. So now that we select it, we have that outline. And when we unselect it, the outline goes away. So that is a cool way of being able to highlight an object. So there's a couple things also that we can do as well. So now that we have this, we can go ahead and create children of it. So let's go ahead and create a material instance. And I'm just going to call this MI for material instance underscore, and we'll call this yellow outline. And under our post-process volume, under our post-process material, if I take this and drop this in and open this up, I now have all of my values here that I can be able to adjust. So our outline color, let's make this yellow, and let's make the line thickness on this a little bit bigger. Let's double it, let's go with 6. And we hit play. Now, when we come to our item, we can see that it is being highlighted in yellow. So this is a really cool way that we can be able to choose to highlight our items. Now, if you look very carefully, you can see how it's kind of shimmering a bit, and that is something that we can solve pretty easily. That's just because of the post-process temporal anti-aliasing that's automatically set. So in order to be able to turn that off, we just come over to our project settings. Then we'll come down to rendering, and we can update this method from TAA to FXAA. That's not going to really do anything, as you see here, because we're not specifically targeting our post-processing. So we come back to here. We want to look for our post-processing this way. Here we go. So how we have custom depth, stencil pass, custom depth with TemperalAA jitter. If we just uncheck that, we come back here, we hit play. We now have a solid line that doesn't have any of that jitter. So that's how we can be able to highlight any of our stuff, and we can keep creating material instances that we can then use to create different outlines. So again, I'm going to take this back down to 3 because I like that. And that is how we can be able to control how an item gets highlighted, which is really cool. And that's going to wrap up this video. And the next one, we're going to build our interaction widget that's going to display information from our objects once it's being viewed. As always, I appreciate you all for watching. Don't forget to like and subscribe for more series like this. And leave a comment down below telling me about a game that you've seen this type of system in. I'm curious to see how many games do this. Happy developing.